Okay, so in this compound inequality, we're asked to solve 5 over 4x plus 1 half less than or equal to 151 over 32, or negative 6 over 7x plus 23 over 7 greater than or equal to 23 over 7, and then graph the solution set. All right, so our first inequality here is 5 fourths x plus 1 half less than or equal to 151 over 32. And each, we have fractions. And I like to build up the fractions to have the least common denominator, in this case, which is 32. And then most people like to multiply through. I like to build up the fractions so they have the common denominator. So I'm going to multiply top and bottom of this fraction by, not 32, but by 8. And the second one here, 1 half, by 16. Excuse me. And this one by 1, because it already has 32. So then that would give us a new inequality, equivalent to inequality, 40 over 32x plus 16 over 32 less than or equal to 151 over 32. All right, then I say forget about the denominators because they're not going to contribute anything no more. If you think, you could think of it as multiplying through by the LCD, and they cancel. All right, so now we have this inequality, and I'm going to go ahead and isolate the 40x by subtracting 16 on both sides, and that would give me 40x less than or equal to 135, and then I would divide both sides by 40. So this way I get x is less than or equal to 135 over 40. They share 5 in common, so dividing out a 5 in top and bottom there would give me 27 over 8. Okay, so remember, or, right? This is an or statement here. We can work simultaneously. I don't know if I need that many ors, but we'll see. All right, once again, we have negative 6 over 7x plus 23 over 7 greater than or equal to 23 over 7. They all have a common denominator already, 7, and so we could forget about it or multiply through by the LCD, okay, which is 7. So that gives us negative 6x plus 23 greater than or equal to 23. And I would isolate the x by subtracting 23 on both sides. That would give us negative 6x greater than or equal to 0. And then I would divide negative 6x by negative 6. But when we do that, remembering properties of inequalities, that makes this switch to less than or equal instead of greater than or equal in this case. So then we get 0 divided by negative 6. So we got the inequality x is less than or equal to 0. All right, well, in set builder notation, the solution set is the set of x such that x is less than or equal to 27 over 8, or x is less than or equal to 0. Now, if you realize this here, or, we would have all the numbers that are less than 27 over 8, or x is less than 0. Now, every number that's less than 0 is also going to satisfy x is less than or equal to 27 over 8. Therefore, this interval here is going to, or the set builder notation can simplify it as x is less than or equal to just 27 over 8, because this x less than or equal to 0 is just being redundant, since every number less than or equal to 27 over 8 that is less than 0 is going to also satisfy that inequality. So it's either or, right? So it has to satisfy either or, and therefore that reduces to just x less than or equal to 27 over 8. All right, in interval notation, that would be negative infinity to 0, not 0, but 27 over 8, and then bracket. Okay, so then if we're going to graph our solution set, we would have too big of a line there. All right, so then we would have, say, negative 1, 0, 1, 2, 3, 4, 5 maybe. And then just to remind ourselves, 27 over 8, It's easier to think of it as a mixed number when you're plotting this. So we know 8 goes in 27 3 times, and that would leave us with a remainder of 3 over 8. And so it's 3 and 3 eighths, so a little bit closer to 3 than it is to 4. So it's about right about there. That's 27 over 8. And it's a filled in circle, and you would shade everything to its left.